Can somebody speak to check the audio?
Hello, this is Dr. Riyaz. Am I audible, sir?
Yes, I'm able to hear you.
Thank you.
Can somebody from Gates acknowledge?
Yeah, sir, your voice is audible.
Could you hear Dr. Riyaz?
Yeah, speaker sir's voice is also audible, sir.
Okay. Thank you. Thank you.
Respected dignitaries, participants from the various institutions, and my dear colleagues, a very warm good morning to one and all. I, Varlin Betty Cruz, Assistant Professor, Department of Electronics and Communication Engineering, delighted to welcome you all on behalf of Gates Institute of Technology for the 5-day faculty development program on advanced technologies and challenges in electronics and communication engineering, organized by Department of ECE, Gates Institute of Technology, Gutti. Learning gives creativity, creativity leads to thinking. Thinking leads to knowledge, and knowledge makes you great. It is my pleasure to invite the convener to this faculty development program and head of the department, Mr. M. Imtiaz Basha sir, to address the gathering.
Thank you, madam. Distinguished keynote speakers from premier institutions, delegates, colleagues, ladies and gentlemen, good morning. On behalf of Electronics and Communication Engineering Department, Gates Institute of Technology, I am delighted to welcome you this morning to a 5-day faculty development program on advanced technologies and challenges in electronics and communication engineering. Technologies evolve continuously due to innovations, discoveries, and business requirements in today's ever-advancing world. Electronics and communication being one of the major divisions of evolving technologies, recent developments and advancements are happening at a fast pace. it is imperative and challenging for the educationists teaching in these technologies to keep pace with these developments and advancements, not only for updating their own knowledge, but also for the knowledge to the community of students and research scholars. By analyzing, understanding, and contributing to the evolution of emerging technologies, faculty members teaching in electronics and communication will be well equipped to solve today problems of mankind and societies, thereby contributing to the growth potential of the nation and the world. Technologies such as Internet of Things, industrial automation, Industry 4.0, robotics, 3D printing, 5G technologies, blockchain technologies, artificial intelligence, and machine learning offer a wide range of opportunities to professionals and students. This FDP will provide a platform for the exchange of these new ideas, thoughts, and realizations on challenges and advanced technologies in the areas of electronics and communication. Thank you for being here on this virtual platform and to bring your energy, ideas, and expertise. And we have participants from the different parts of the country. I would like to welcome and give special thanks to our Managing Director, Sri G. Raghunath Reddy Garu, our correspondent, Srimati V.K. Padmavathamma Garu, our Director, Srimati V.K. Srivani Garu, and our beloved Principal, Dr. Venkatesh Garu, for their suggestions and support, and my team who have been supported me throughout this program right from its inception. And I welcome and thank today's chief guest, Dr. D. Vishnuvardhan sir, Associate Professor and HOD, Department of ECE, JNTUA, College of Engineering, Anantapur, for giving his valuable time for us in spite of his busy schedule. Gates Institute of Technology was established in 2001, is permanently affiliated to JNTUA and accredited by NAT. The institution also got recognition of 2F and 12B from UGC. Institution is certified by ISO. The focus is to inculcate continuous learning habit with positive attitude and ethically sound values within the faculty and students. The institute has always envisioned instilling life skills among the students through their participation in various curricular, extracurricular, and co-curricular activities. The Department of ECE regularly conducts Project Expo, Idea Club meetings, quiz programs, poster presentations, hackathons, seminars, and symposiums, thereby enhancing the competence and confidence of the engineers graduating from this institution. Eminent speakers from industry and academia are regularly invited to the Department of ECE to give presentations and guest lectures with an aim to engage and motivate the students to acquire knowledge in the latest trends and advanced topics of ECE. Department of ECE works in close collaboration with many organizations such as Atal Innovation Mission, Andhra Pradesh State Skill Development Corporation, Indian Institute of Remote Sensing of Indian Space Research Organization, Florida Atlantic University, and UiPath, in order to train the students in the state of art and advanced topics of ECE such as IoT, remote sensing, 5G, video processing, and machine intelligence. Progressive thinking of our late correspondent Sri V.K. Sudhireddy Garu has made Gates stand tall as one of the very first and few educational institutions to completely run on solar power. Institution is headed by Dynamic Managing Director Sri G. Raghunath Reddy Garu, correspondent Srimati V.K. Padmavathamma Garu, who is the heart and soul of our institution, and Director Srimati V.K. Srivani Garu, who is giving a new direction to the institute. So thank you, sir. Thank you very much for giving me this opportunity. So have a nice day for 5-day insight of FDP. Thank you.
Thank you, sir. Thank you very much for giving your valuable insight on FDP. Now, I would like to request the co-convener, Dr. RS Kavita Madam to give a brief introduction about the chief guest of this program.
Good morning, respected dignitaries. I, Dr. Kavita RS, would like to have the privilege of introducing our chief guest, Dr. D. Vishnuvardhan Sir, Associate Professor and HOD, AC Department, JNU College of Engineering, Anantapur. Sir, we extend hearty welcome to you. Introduction of the legend goes this way. Sir has been graduated from RGM College of Engineering and Technology, Nandyal in the year 2000 and has attained his Masters in Computer and Communication from JNU College of Engineering, Kakinada. He has been awarded doctorate from JNU, Anantapur. Sir has very rich experience of academia since 2001 till date as Assistant Professor and Associate Professor in JNU Pulivendana, JNU Kalkiri, and JNU Anantapur. He is life member of IE, ISTE, and IAENG. In the pursuit of helping student community, he has organized workshop titled Campus to Carry National Level Tech Symposiums. In the course of updating himself, he has attended innumerable workshops, training programs, summer courses, orientation courses, and winter schools. He has vitally contributed to the area of research by publishing 56 international journals, attending 9 international and 15 national conferences. He has published 2 patents and authored a textbook. Sir is now leading Department of EC, JNU College of Engineering as a dynamic HOD. Sir, we faculty and students are always inspired by your knowledge. We feel lucky to have you here, sir. We are grateful to you for sparing your valuable time for us. Now I request you to address the gathering, sir. Thank you.
Sir, your voice is not audible, sir.
Am I audible?
Yes, sir. Now your voice is audible.
Sir, we are not getting voice, sir.
Am I audible? Am I audible?
Yes, sir.
Yes,
Yes,
sir.
sir. Now it's audible.
Thank you. Respected Srimati B.K. Padmavatama garu, correspondent, Gates Institute of Technology. Respected Sri G. Raghunath Reddy garu, Managing Director, Gates Institute of Technology. Respected Srimati B.K. Srivani garu, Director, Gates Institute of Technology. Principal of the college, Dr. D. Venkatesh garu. Convener for National Level Online Faculty Development Program and Head of the Department, Sri M. Riyaz Basha garu. Coordinators for this program, Dr. B. Manan garu and Dr. R.S. Kavita garu. Resource persons for the Faculty Development Program, Dr. Mohammed, Riyaz Ahmed garu, Assistant Director of Multidisciplinary Studies, REVA University, Bengaluru. Dr. Abhishek Adhikari garu, Assistant Professor, IIT Bilal. Sri Vasu garu, Assistant Professor and Research Scholar, NIT Trichopalli. Sri Ratnadeep garu, Head Engineering Division, Vmware Lighting Systems, Pune. Sri Kotesh garu, Director and CEO, Indian Techies, Bengaluru. Participants for this program, organizers, invitees for this program, a very good morning to all of you. At the outset, I extend my sincere thanks to the college management for inviting me to this inaugural function. I appreciate the Department of ECE, Gates Institute of Technology for organizing national level online faculty development program on advanced technologies and challenges in electronics and communication. Now, if we are talking about the benefit of the human race, then advancement in technology is crucial. Many problems which we cannot yet solve or understand exist due to lack of technological advancement. The advanced technologies help mankind. It also helps people to solve their problems, reduce excess time, save lives, and help to interact and exchange information. Another benefit of technology advancement is that it increases your profits. You can increase profits by increasing sales or reducing your costs. Advancements in technology can make significant contribution and support to many areas. I do not believe we humans will stop innovating and excelling with technology, since there are those who cannot live with no answer to a problem. But do keep in mind, as technology advances, the difficulty of the matter also increases as well. Overall advancement in technology is necessary if the human race is to survive. If the engineers stopped with the first generation and never bothered to create efficiency, how do we think our skies would like now? I am sure we'd be far worse than what we are today. Coming to the electronics and communication engineering, we are seeing the tremendous developments related to technology in VLSI and communications. These types of programs will help the faculty to get exposure of the latest developments in the field of electronics and communication engineering, and further, those who are particularly in research get lot of problem areas and they can take it further. It is also the platform for the faculty who wish to begin their research work. And also the resource persons drafted for this program are from both academia and industry. Organizing these type of programs is not an easy task. It involves a lot of effort in coordinating with academicians and industry programs, industry persons in bringing out the program. I wish all the participants to actively participate in all the deliberations and get enriched knowledge in advancements in technology. I wish this program will reach the expectations of the participants. Finally, I thank all the organizers for giving me an opportunity to say a few words on this occasion. Thank you, one and all.
Thank you, sir. Thanks for enlightening us with your inspirational words about the advancements and technologies in ECE. We will try to make the best use of the program to improve our skills. And I thank you very much for your inspiring words. And we are thankful that you have accepted our request and graced the occasion in spite of your busy schedule. Thank you, sir. Thank you very much.
Thank you.
Now, I request our Honorable Correspondent, Srimati V.K. Padmavatamma Garu, to speak few words.
Good morning, everybody. I am V.K. Padmavatamma, Correspondent of Gates Institute of Technology. It gives me immense pleasure to see the teaching faculty being connected through this platform. I congratulate ECE Department of Gates Institute of Technology to innovate this activity, a 5-day online faculty development program on advanced technologies and challenges in electronics and communication engineering. I thank Dr. Vishnuvardhan sir, HOD, Department of ECE, JNTU Anantapur, as a chief guest, accepting this invitation on this inaugural session and motivating the participants for this program. I also thank all the eminent speakers for accepting the invitation to share their knowledge. This kind of platform provides educators, faculty, and research scholars to improve the quality education and imparting the same to the next generation. I wish all the participants will make the best use of it and equip themselves to provide good research and quality education. And I wish all the best for all the participants. Thank you all and wish you all the best for the next program.
Thank you, ma'am. Sure, we will try to make the best use of this program to improve our skills. Now, I request our young and dynamic director, Mrs. V.K. Srivani Madam, to speak a few words.
Good morning, one and all. It gives me immense pleasure to be part of this inaugural program of the faculty development program that our ECE department is hosting. And I thank Dr. D. Vishnuvardhan sir, head of the ECE department, JNTUA, for accepting our invitation to be the guest of this event, chief guest of this occasion. And also I thank all the eminent speakers and today's speaker, Dr. Mohammed Riyaz Ahmed Garu, for accepting the invitation and being a speaker for today's faculty development program. I thank you all. And I wish all the participants who have registered for this program will benefit out of this program and will have some take-home points, and that will help them in their research and also educating their students. Because in this changing world, we have to update on the technologies, because every day we are seeing the new trends, and to catch up with those things, these kind of FDPs will benefit us. And I think you'll all make most of this program. And I congratulate all our ECE department who has put in a lot of efforts to put forth this program. I congratulate them and best wishes to all of you who are taking part of this program. Thank you.
Thank you, ma'am. Sure, we will try to make the best use of this program to improve our skills in the advancements and technologies regarding ECE. Now, I would like to request our beloved principal, Dr. D. Venkatesh sir, to address the gathering.
Honorable Chief Guest of today's function, Dr. D. Vishnuvardhan Garu, HOD, Department of Electronics and Communication Engineering, JNTU College of Engineering, Anantapuram, distinguished correspondent of the institution, Srimati V.K. Padmavati Madam, the young, energetic managing director of our institution, Shri G. Raghunath Reddy sir, respected director, Srimati V.K. Srivani Madam, resource person for today's program, Dr. Mohammed Riyaz Ahmed Garu, HOD of ECE department, Mr. Imtiaz Basha Garu, coordinators of the event, Dr. B. Mannan Garu and Dr. R.S. Kavita Madam, dear colleagues and participants, a warm welcome to the 5 days online faculty development program, which is organized by Department of Electronics and Communication, Gates Institute of Technology, entitled with Advanced Technologies and Challenges in Electronics and Communication Engineering. First of all, my sincere thanks to all the management and the principals for permitting the faculty to attend this FDP program. It is my proud privilege to share the dais with all such eminent personalities. The main use of this faculty development programs is to enhance our knowledge. We, the teachers, should give the proper and the right information to the students. We, the faculty members, don't have the sufficient time to learn new technologies directly. Whereas this type of faculty development programs will provide an opportunity to learn the new things, develop the network, exchange the information, and motivate ourselves to learn the new technologies. Coming to this FDP faculty development program, that is the advanced technologies and challenges, it is very well selected by the Department of Electronics and Communication Engineering Department of our institution, because nowadays, as pointed out by our director, madam, change is inevitable. We need to change according to the environment. If you are not accepting the change, that means we cannot survive in this world. So this title will provide you what are the advanced technologies that we are going to encounter in ECE field, and what are the things that are going behind this one, and how to learn the things can be gained from this faculty development program. My sincere thanks to all the organizers and the Department of ECE to coming forward to organize the event like this. Oh, thank you everyone for giving me the opportunity.
Thank you, sir. Thanks for your inspiring and motivational words. Now, I request Mr. A. Amreshwara Kumar sir to give a brief introduction about the speaker for today's session.
Thank you, ma'am. A very pleasant good morning to all, and welcome to 5 days faculty development program on advanced technologies and challenges in electronics and communication engineering. Dear participants, thank you taking time out and being here today. On behalf of Gates Institute of Technology and on behalf of Department of ECE, I'd like to give a warm welcome to the honorable speaker of today, Dr. Mohammed Riyaz Ahmed sir. Dr. Mohammed Riyaz Ahmed sir once said, "My strongest conviction is that no matter what syllabus is, it should be served with an intention to bring awareness and has to be received with the utmost attention." Dr. Mohammed Riyaz Ahmed is an associate professor and assistant director in the School of Multidisciplinary Studies at REVA University, Bengaluru. He did his BE in Electronics and Communication Engineering in 2007, MTech in Computer Networking in 2010, PGDBA in HR and Business Administration in 2012, and PhD in Reinforcement Learning in 2016. Recently, he has developed an interest in design thinking and is pursuing research in implementing design thinking for entrepreneurial universities to generate knowledge economy. His primary areas of teaching are circuit theory, field theory, integrated circuits, control systems, CMOS VLSI, microwave, and RF communication engineering. He also teaches multidisciplinary topics like design thinking, engineering innovation design, and nurtures budding entrepreneurs in his Impact Incubation Center at REVA University. Dr. Riyaz is a senior member of Institute of Electrical and Electronics Engineers, a lifetime member of Indian Society for Technical Education and IETE India. He is a practicing teacher and believes in activity-based learning. He is a practitioner of learner-centric pedagogical methods and experiments with the diverse ways of teaching and learning. He is a good counselor, motivator, and has mentored over 40 UZ and 24 PG projects, out of which 3 projects bagged Best Project Awards and 65 papers have been published in indexed journals and conferences under his guidance. He has filed 10 patents and 1 international patent is granted for his innovation. He has consultancy and funded projects to his credits in the areas of green technology. He is a recognized mentor and his student projects explore the areas of smart cities, technology intervention for elderly people, artificial intelligence, and analog VLSI design. Mohammed Riyaz Ahmed sir conducts research with fellow colleagues and interested students for solving the 17 Sustainable Development Goals. Dr. Mohammed Riyaz Ahmed sir once said, "Don't debug a program. Instead, teach the program how to debug. The system will never fail." So, thank you, sir. You spared a crucial time from your busy schedule. We all are eagerly waiting to listen enriched knowledge. I hand over the session to you, sir. Once again, I'm thankful to you, sir.
Thank you, sir. Let me confirm whether my audio is audible to all of you.
Yeah, sir, your voice is audible.
Thank you, madam. Thank you, Gates Institute of Technology, especially the Department of EC, for giving such an opportunity. If I get some time to thank, I would like to thank the esteemed management people, Srimati VK Padmavatama madam, who is correspondent. Also, Ms. VK Sriwani, Director of Gates Institute. Principal Sir, Dr. D. Venkatesh, today's Chief Guest Vishwardhan Sir, and the co-convener Dr. R.S. Kavita Madam. Thank you one and all for giving me this opportunity. And the title is very thought properly and apt for the current situation. And I hope I would make some justification. And I'm also lucky that I get the session on the very first day. Whenever there are speakers lined up, if you are the last speaker, 70% of your contents or the keywords will be already used in the session. So it will be very fortunate to have first session so that everything what we say will be received with utmost attention. Thank you. And with your permission, I would like to share the screen and would like to start the session. And I also appreciate the time management of Gates Institute of Technology. As promised, I will get the handle of the Zoom by 11:30. You have handled it, you have handed it to me by 11:29. I respect this kind of discipline, and I'm sure that anything which is having precision in small habits will always grow. And I pray for a very bright future for Gates Institute of Technology and all the faculties working there, so that they can synergetically coexist there and see that they and their organization is growing, and there is a win-win situation for anybody who comes in. Thank you one and all. Shall I proceed with the session?
Thank you, sir. We are pleased to have you here. So we can start the session, sir.
Thank you. If I can share the screen.
Yes, sir.
I think first you have to unshare the screen so that I can share. I will have the privilege once there is no screen shared. Thank you. So I hope my desktop is visible.
Yeah, sir. We can see your screen, sir. It's visible.
Yeah. And also I would like to know whether the participants can unmute and answer during the session, because it is online. I would like to have interaction. There is a provision. Like the participants can unmute and answer while I throw some questions during the discussion. Is it possible, ma'am?
Sir, the participants will post the questions in the YouTube, sir.
Okay. So it
And
is
we can read it for you, sir.
sure. So it is live stream, right?
Yeah, for the
Okay.
last 10 minutes of the session, we can go for the question part.
No issue. So will you be helping me if they are typing some answers? Is that okay?
Yeah, sir. If they are posting, we will read it to you, sir.
Done. Thank you, madam. So there is a new way of pedagogy where most of the sessions will be presentation based. And whenever I give presentation, and this is the experience of many of the teachers in the last 2 years, where we have shifted from offline domain to online digital domain. And I see that, and we all see that there is a lack of attention whenever there is a session, online session. So here I'm trying a new kind of interactive session where I will be building the material in front of you, okay, with your assistance while I impart the knowledge while we discuss all these things at the real time. Okay, so let me design the complete document in front of you so that you will be part of it. And I'm sure, I hope this will work and it will keep ourselves engaged.
Yeah, sir.
So I would like to take a small table like this, and let me start from the physical world. So in the physical world, what we will do, let us deploy some sensor. Okay, so this sensor will help me in multiple ways. Like it will try to see some change which is physical or sometimes physiological, or even any environmental changes. Okay. So there is a small event in the environment, and now this has to be sensed. So when we sense that, how do I sense first thing? And when we sense, what is the outcome, what we have? So the first thing is, how do I sense? I sense the things using sensors. And any device which has a sensor is called to be smart. Okay. So there is a difference between intelligent device and a smart device. And let me bifurcate that here. A smart device is a device which has sensors in that. Intelligence, I'll define it somewhat later. Coming to smart devices, if the sensor is detecting the event and it is giving the actuation, that is act, sense and act, then it is called as a smart device. For example, we call our phones as smartphones because there are 38 basic sensors embedded in that, and the sensors will increase as we go on adding the sophistications. Okay, so when I add these sensors to any devices, they become smart devices. That means they can sense their environment. Okay, so they are able to sense the environment, and not only they will sense, and they will act accordingly. For example, if I tilt my cell phone from vertical to horizontal mode, the screen display, it will switch from vertical layout to horizontal layout. So the gyroscope is the sensor which has sensed that the gravity has changed and the phone is not viewed in vertical mode, but it is viewed in horizontal mode. So the moment I do that, the gyroscope will sense and it will act accordingly, and it will switch the layout from vertical landscape to horizontal. So a device which has sensors is called as a smart device. Now these smart devices will give me enormous amount of data. Okay, so these smart devices will give me huge number of data. Now how many smart devices I have, those many number of devices will contribute to the data. Now when I see such a large chunk of data, I will call that as, can anybody type the answer? When there is huge data, that large data in today's technology is called as, Am I expecting some answer? When the sensors sense large events in the environment, they generate huge amount of data, almost like every day 59 trillion GB of data is generated from all the devices, the smart devices. This large data is called as, if there's anybody who has typed the answer, please let me know. Because we will have at least 50 terminologies here and I want it to come from your side. I thought of making more interactive.
Sir, they have posted the answer as
Yes.
big data.
Very good, very good. Please keep me in the loop, madam, and you speak up whenever there is an answer. Okay, because
Yeah, sir, sure.
yeah, because there are so many terminologies. The topic is like that, advanced topics in electronics. So I will be taking everyone through all the terminologies and how they are relevant. So kindly be patient and bear me, and please speak out the answers whenever they are typing.
Yeah, sir, I'll be posting it to you.
Yeah, thank you. So this data, the big data, it is not a small thing and there is a large chunk of data. Now, if you are an electronics engineer, okay, if I come to the large domain of data, whenever there is a huge data, what electronics engineer should do? What facilities they should provide? When there is large data, what an electronics engineer should focus on? What kind of solutions an electronics engineer should focus in their research or development or product development or entrepreneurship or a startup? Whenever there is a huge data, what is expected from electronics engineer? What kind of solution is expected from electronics engineer? Can you post, any of you can post the answers? Will this work? This arrangement will work, madam? Can we?
Yeah, sir, I'm waiting for the answers.
Okay.
So they have posted like has to process to extract the information.
Okay, very good, very good. I will take that. Very good. So I will take that here because I should process the data, and before processing the data, it should be somewhere. The big data has come and the data is keeping on coming. So before processing, what should I do? It should be somewhere. So it has to be stored somewhere. So an electronics engineer should provide devices which has large storage capacity. That means we have to rework our memory. The way the memory we have designed in computers right now should be reworked. The way the storage happens, it has to be escalated to a large scale and it has to be stored for a long time and it has to be efficient and optimized. So coming back to this big data, when there is huge data and I want to get insights out of that, so what should I do? When there is a data and I want to get insights from that, what should I do?
So there's another comment. They have posted it regarding the reduction of dimensionality.
Okay, very good, very good. Reduction of dimension here. Excellent. I think the session is going to be interesting. The answers are very broad and very apt to the situation. Okay, coming back to the insights. If I want to get insights from the big data, what should I do on the data?
So there's another comment
Mhm.
for analyzing the data and to extract the information.
Thank you. Exactly. So we have to work on data analysis. Okay. So there will be many things where we will be doing predictive analysis. Okay. And we will be doing schematic analysis and sentimental analysis on social network, especially. So these are the things what we do on data. So that means there is a huge data which is coming in the network, and this data has much of information which has to be given. And before we go to the information panel, let me write this as a data plane. So this is information plane. So then we will have intelligence plane. Okay. And I'll try to merge information and intelligence so that we can have more discussion on these things here. So this is where the market is trending now. So there are sensors which have been deployed, and there is a large accumulation of data, which is called as big data. And this big data is analyzed to find out some insights in that. And that can be done by data analysis. And data analysis have multiple types, where actually I'm talking about predictive analysis and sentimental analysis. And anybody who does this are called as data engineers. So they are also called as data scientists. So data engineers who work with the statistical advanced improvements, which is nothing but decision-making capability. And when there is a decision-making capability, the data will give us insights about the large chunk of data, which makes no sense, but after analysis, it will make some sense out of that. And when I have analytics, when I have analyzed the data, now I want to take some decisions. When the analysis is done, I want to take some decisions. So that means if I am capable of taking decisions, I will be called as, if I am able to take decisions, I will be called as
Decision making.
decision maker. I am autonomous and intelligent. Now, this is a big word which has been used, sometimes abused over the technology. Before I say a machine is intelligent, it should exhibit few things. That means the very important thing is it should take decisions. If it is able to take decisions, then the machine is said to be intelligent. So this is the domain of intelligence, artificial intelligence. Since we cannot give any natural intelligence to them, we are yet in the pursuit of achieving artificial intelligence. And when can a machine be intelligent? Can anybody tell me, when can a machine be intelligent?
When we train them.
Okay, that means when we train them and when the machines start learning. Okay. So training is an old kind of pedagogy, madam. Since we are also working on outcome-based education, we always focus on learning. So I would like to remove this term of training. And when the machines start learning, okay, then they can take decisions. And when the machine is learning, then it will take decisions. And when it is taking decisions, I can say that the machine is intelligent. So this is how we can bring a new arena of devices. The machines should not only be processing the information, but they should be intelligent. Now coming to this, I have to say, if the information has to be processed, if the information needs to be processed very fast, then I cannot work with current computing systems. Then I need more power, that is serial processing may not suffice. So we have to go for parallel processing. Okay. And when we do parallel processing, then we can achieve more fast decisions. And also there is one more thing what I want to highlight is, just because of learning and taking decisions, the machine cannot be intelligent. A machine should see. A machine should listen. Okay. Now, can you tell me which are the domains which help machines to see, which help the computers to have a vision to the things which we may not see or which we can see or which is under our capacity to see at that minute level? Which domain of engineering will deal with that so that the machines can see, the computers can have a vision? Can I expect answers? I'm missing offline interaction, but I would like to make it as impactful as possible in this way.
So, image processing.
Image processing is a very broad name, and its application, I will call it as computer vision. So image processing, which will process any given image. But here, if I take a video, if I take an image, a still image, if I can make sense out of that, that is nothing but image processing. And the technology trend, what they are calling it as, it is computer vision. Now the question is, if the machines can listen, what do you call it as? Or what is the domain which deals with the capacity of enabling machines to listen? I can give an example of Alexa and Siri. So what is the domain which deals with this? What do we call it as? Just like computer vision helps, or computer vision says that yes, machines can see. What domain will say that yes, machines can listen? There are a number of domains and terminologies, so I want to bring it out from you so that you can remember it for a long.
So someone has committed as robotics.
No, because robotics is about the action, act. So I will come to that in physical layer again at the end. It will be communication and application layer.
So we got another comment, mechatronics.
Both are same. Mechatronics and robotics, they are same. Can I get much better option, more precise option? Like if the machines can listen, Alexa and Siri, I have given you the example.
Sir, artificial intelligence.
Oh yes, we are in the domain of artificial intelligence, and we are telling the machine is intelligent because it is able to listen. And we are also telling the machine is intelligent because it is able to see. That is computer vision. So in the same way, when it is able to listen, what do we call that particular domain which works with that? If I want my machine to listen, what should be there? For example, if I want my system to see, then there should be computer vision in that. Let us wait. This is the most important domain which is buzz in the market, and it has to get attention, and many people have to
So
work.
we got another answer. Speech recognition.
Very good, very good, very good. Now I will call it as natural language processing, and which is nothing but, as you said, C is about image processing, listen is about speech processing. So listen is a property, or listen is an enablement of a machine where it is called as a natural language processor. If you speak, it has to listen to you. So natural language processing is a domain which many people are working on that, and many research are happening in this area. Now I will bring you back from here, from seeing and listening to electronics domain. If I want to see, what should be the device? Coming to hardware. if I want the machines to see, what should be the device? Coming back to image processing, what should be the input device for an image to get an image? Should be
Lens.
yeah, high definition camera with very good lens. So that would be one of the input device. So if you are an electronics engineer and if you want to implement computer vision and you want to do research on that, let me tell you, you have to have a area where you are going to work with a high definition camera or a lens. Or if the data is very high, you have to compress it first. That means you come back here when you become a data engineer here. Being an electronics engineer, you have to work on data compression. Now, why data compression by electronics engineer? Because electronics engineers know transforms. Okay, they know how to play with the signals in various domains, in frequency domain and in time domain, and also in Laplace domain. They know the region of convergence of that. They know the region of divergence of that. They know the ROI, region of interest. So, electronics engineer who works on data, if he has another capability of compressing the data, then it is much appreciated in the industry. So being an electronics engineer, if you are working on data compression, you cannot neglect the application of computer vision. So you have to focus on computer vision and then you have to work on data compression while at the background you are a scientist, that is data scientist. So this will help you to get a better reachability, and when you work on such things, you will be reached by many people. Your papers will be cited by many people. Okay, so these are the things what I wanted to tell in the term of computer vision. Now coming to a listening capability, that is, as one of the participants said, it is about speech processing, where we need to have ears which listen. That means whatever has been spoken, independent of the accent, it has to be converted into text, and then it has to be converted into bits, and it has to be processed. So that has to be done at electronics domain level. So this is about making a machine intelligent in computer science domain. This is what is computer science domain, and this is electronics domain. So when we talk about listening, it is about natural language processing. Now coming back to electronics engineering again, from there, I would like to first talk about the emerging technologies here when the data is huge. A data engineer will see the data, and that data cannot be stored in everybody's system. So it has to be centralized and it has to be stored somewhere. Can the participants recommend me where the data should be stored? The big data to be stored, where the data has to be stored, not information.
In the cloud.
Very good, very good. Thank you. So cloud is the largest resource which helps us to store all the data. Many times we might not be generating the data, but we will be working on the data. For example, a Michigan University might have collected images of weather for last 15 years. Now they are predicting the weather for next 5 years. They want to see what level of rain is happening. Being in India, we can compute that using the same data because that data is available on cloud. So when you work on the data, that means when you start doing computing on the data, which is in cloud, then it is called as cloud computing. So this is a biggest advantage what we have, and that will help us to have data analysis at the level of cloud, and it is a centralized way which will help many domains like supply chain and medicine. Now, there are also disadvantages associated with cloud computing because cloud is centralized. Every time we have to go to the cloud, every small instance has to be sent to the cloud. And whenever you start sending to the cloud and receiving that, then you will have a large overhead. You will have a large overhead. So instead of that, what I will try to do, this is very important part of discussion. I will ship all the learning models, the trained models, to the edge, not on the cloud, but on the edge. So when I send all the things to edge, then it is called as edge computing. Remember that I have used a word called as shipping. So I want to ship the complete thing, but here, if the computing is done in cloud, it is called as cloud computing. But if the computing is done at the edge, then it is called as edge computing. But I want to take that word here, shipment. So you want to ship one particular process from one place to another place. Okay, so you want the computing capacity of the cloud to be shifted towards edge, and edge is a place where our sensors are located. Okay, so that means if your Apple Watch, if the Apple Watch is detecting that your heartbeat count per minute, it should also have the intelligence to take decisions accordingly. And if there is some abnormal variation, if there is something abnormality observed, then that has to take some decision. Previously, what it used to do, it will send it to cloud and wait for the response, and the cloud will process it, and that will be sent again back to the device. But now we are transferring the complete computing capability from cloud to edge via shipment. Coming to shipment, how do you do shipment? If you see the harbors, okay, there will be large containers, right? And the containers are fully packed. You don't know what kind of material is inside. Even if it is cotton, the container is same. Even if it is metal, the container is same. So that means a container is self-sufficient package which is able to execute on itself. Okay, so the same type of containers are used to have such machine learning capability, okay, in hardware devices. So when I cannot achieve parallel processing, or when I cannot use high speed computing, then what I will do, I will virtualize a machine. Okay, this is called as VMware, virtualization of hardware. So a virtualization of hardware is created on which containers are docked. Now coming to the dock, there is one more word called as Docker system. A ship will be loaded or unloaded. A ship will be loaded or unloaded at the dock. So whenever you want to ship a software, it has to be made as a container. That means it is a self-sufficient package. This container is a bundle of softwares where it is consisting of app, the libraries, and the dependent tools, which will help that particular app application to run independently. So containers are self-sufficient. They can be like isolated part of softwares. They are isolated part of these softwares which will be docked. Now, what is Docker? The important work of Docker is to help the container to run independent of hardware. So this is one advantage for electronics engineers, where you have to just create a high computing hardware, fast computing hardware, and leave it. Anything, there is no need of worrying about that. Like for example, if some application is developed in Linux, if you have a Docker, even if your operating system is not Linux, still it will work. That means you have to focus on only the hardware. And when you have such kind of high demand kind of applications, what we have to focus is about hardware accelerators. These hardware accelerators will help me to achieve fastest computing thing, whatever is required as per the machine learning we are using, especially when we are going for deep learning. So the hardware accelerator, one of the biggest company which has grabbed the complete market or because of their hardware accelerators. Can anybody let me know? Like they are the master in GPUs. They have occupied the complete market. Previously it was CPU. Now when you want to see, that means there is some graphical content. When you want to listen, there is some graphical content. So when you have graphical content, your central processing system has its own limitations. You cannot use your CPU for all such things. So Intel chips are running out of their capacity to run such high-end things. So electronics engineer should go beyond CPUs, that is GPUs. Can anybody let me know which is the organization or company which has occupied 85% of the market of GPU? The industry which is working with GPUs, and it has occupied almost 85% of the market as compared to Intel, which has to yet migrate to GPU or is in the process, or they have their own versions, but this company has taken over the market. Hardware accelerators, most of their boards, motherboards are released with GPU versions and they are in huge market. Can anybody let me know which is the company?
Sir, FPGA.
Yes, FPGA is a like a springboard for me where I can dump some circuits and test them. I want a company which is working with GPUs, which is producing GPUs. FPGA, of course, is the platform where we will test all these hardware accelerators. As Madam said, only FPGAs are the best option for us to test hardware accelerators. But can you tell me the company, because that is going to be the future employers. That company is going to be the future employer if we are working on hardware accelerator. And if you are working with deep learning algorithms implementing on hardware, then that is a company which is looking for such engineers. Can anybody Google and let me know the answer? Participants.
So the thing is, we have a delay in the Zoom and the YouTube, sir.
Okay.
30 seconds delay. So we are getting a late response.
Delayed response. Okay,
Yeah.
okay. So then I think we have to upgrade to 5G so that the latency can be reduced. So I'll move to 5G very soon then. Okay, man.
Sure, we do.
Yeah. So then let me tell that it is NVIDIA, which is occupying the complete market of graphical processing units. So anybody who want to work on hardware accelerators, that is nothing but they have to implement some machine learning algorithm for this kind of application where it is about vision or it is about natural language processing via a container. Okay, via the container and a Docker on the hardware, which is virtualized, and the hardware is accelerated, and it is not a serial processing hardware, it is a parallel processing hardware. So this is the domain what hardware engineers who are interested in implementing machine learning, especially deep learning, can work on. Okay. Since it is computer vision here, I would like to put those learning algorithms here. So deep learning will help us more in understanding the images. Similarly, if you ask me what about natural processing, I would say reinforcement learning. So these are the machine learning algorithms. Machine learning has three categories. One is supervised, another is unsupervised, and one more is reinforced. There is also a new type of learning coming up called as transfer learning, which is very good when you do shipment from cloud to edge. That means the deep learning is trained in cloud, and the deep neural network has learned, and that learned module is shipped to edge. and that is called as transfer learning. So whenever you shift the information or the knowledge from cloud to edge, that kind of learning is called as transfer learning. Okay. I am not bifurcating and I am not going into core VLSI as advanced topic because there are many people who are going to talk about that. I wanted to give a sandwich or interdisciplinary approach where how the people are going behind computing facilities, that is IT industry, and how electronics engineers can pick up to the pace without sacrificing their domain. Being in electronics domain, how they can become data scientists. That is what I told you about. If you are good at data compression, then you can go towards that. Similarly, if you want to be a machine learning specialist, then still you will be working with virtualization and hardware accelerators, where you will implement deep learning algorithms on the hardware, and you will be still AI engineer while being in electronics domain. So this is about an intelligent domain what we are talking about. Now coming back to the storage capacity here, when you have cloud, there are many vendors who are working on that. And if you have a certification in cloud, then you have many options like Amazon Web Services. This is one of the certifications which will promise you a job immediately, either for a fresher or for a faculty who want to work on cloud. This Amazon Web Services, they are providing 28 credits of cloud hours to researchers and scientists and the students also who are working for that. Even there is Microsoft Azure, which is also providing services over cloud, and we also have Google Cloud. So these are the service providers, and these are the tools which will help you. Then that means you need to have certifications in this. So if you are if you want to be a data engineer or a cloud engineer, you have to have certifications on AWS or Azure or Google Cloud, or there are many other vendors. If you have a certification, you will be a data engineer for that particular thing. And even you can take some diploma courses in data analysis so that you can become a data scientist, and you can work on algorithms and also architectures. Then you can become a data engineer. So these are the domains. So when I say you can become a data engineer, it doesn't mean that you have to resign your teaching job and get into industry. That means your research topic can be about data engineering. So tomorrow when you present that, it should be an interdisciplinary topic, and it should be a faculty who has worked on Amazon Web Services, who has worked on Google Cloud, who has worked on Azure, while who also know what kind of storages have changed and what kind of data compression is being done. So these smart devices, when I bring it to electronics domain, they become embedded systems. And when I embed these systems for our everyday, then there will be a large population of devices which will help us to work on these devices. Now, taking this towards the next line here, I took machine learning and I also explained about intelligence. So there are other kind of computing paradigms called as fog computing. Okay, so these things are all there. Now there is a physical world, there is a data plane, there is an information plane. Now I want it to be available seamlessly. So that means I want the computing to be everywhere. Okay, God, just like God is everywhere. So I want the computing to be everywhere. You take a scenario of a Uber car, there is a computer in that. Anything which works with bits is called as a computing device. Anything which works with 0 and 1 is called as a computing device. So there is no need to have a computer completely on the end. So we can have a small tiny computers. So we can have tiny computers where we can provide the availability of all these facilities. So tiny computers like Raspberry Pi and also NVIDIA's Jetson kits, and also there will be some other small devices which will help us to have edge kind of computing. So when you have these small computers, you will have tiny OS in that, and this OS is independent and it is available. It has the docking system in that. Now, designing a Raspberry Pi, designing NVIDIA is the job of an electronics engineer. So we need to have processors. Now these processors, they should not only be fast in computing, but they should also be intelligent in computing. So when I say intelligent, that means the current system, the current VLSI system is not going to help us, because soon we are going to run out the Moore's law, which says that every 2 years, the number of transistors on a single IC are getting doubled. So if we keep on increasing the computing facility, it doesn't mean that the systems will become intelligent. I can make a car more faster by designing a more efficient engine, but I cannot make the car intelligent. If you want the car to be intelligent, it should imitate human intelligence. And to imitate human intelligence, in computer science, they have used neural networks to have that kind of intelligence, and that is where even deep learning has been abstracted from that, like deep neural networks. But how do I bring neural networks in electronics? That is done by neuromorphic engineering. Neuromorphic engineering is a field where the complete architecture of the system is not the way it is with our ALU, arithmetic and logic unit. You have stored something here, you have stored something there. There are registers, move A comma B, AX comma BX, you move the content of AX to BX, then add, then put the carry. So again, once it is processed, the sum is sent to there and the carry is sent to there, the result is sent somewhere, and the data is kept back in the memory units. Neuromorphic engineering is a new type of VLSI, okay, design, which works on in-memory computing. So if you are a VLSI engineer, if you are into hardcore analog mixed mode VLSI, so instead of focusing on just increasing the efficiency and reducing the footprint, carbon footprint, like many topics I see that energy efficient VLSI design, energy efficient adder, energy efficient summer, energy efficient ICs. So those are the research topics, but they are already outdated in the industry. So if you can think about something which has more intelligent part in that, then it is called as in-memory computing. In our brain, there is no separate part as registers, there is no separate part as memory, there is no separate part as processing. The neurons, they store and they process there only, in the site, in the synaptic thing, in the synaptic joint, in the cleft, the data is stored, and more the memory is, the larger memory is, or the long-term memory is, the synaptic clefts will connect more tight. It is like things that fire together, they are wired together. Or if you want to have more connections there, then that means memory is more. So if we can change the complete course of action of VLSI design, neuromorphic engineering is going to answer. If we want to have fast computing things, neuromorphic is not the answer. But if you want intelligent devices, if you want intelligent VLSI, then let me tell you, neuromorphic engineering is the only option what we have. Now, electron spins. We have seen that electron spin and electron moves. And if there is a presence of electron or a flow of electron, then we call it as 1 or 0 according to the convention. And if there is no flow of electrons, we call it as 0. But there is another possibility. So this 0 and 1 are called as bits. Okay, I would have waited for the answer, but as there is more delay, I would rush through that. But here I will wait for some time. 0 and 1 are bits. So anything can be in any of these two states. It can be 0 or 1. Any data can be in any of these states. But I would like to have another kind of representation where there is 100% 0 and there is 100% 1, and there are infinite states between these two. That means there can be 99% 0 and 1% 1. There can be 98.0% 0 and 2% of 1, or there can be 65% of 1 and the remaining 35% as 0. And when I have those many realms, those many possibilities, those many probability, then if you see here how weak this computer is, this computer has only two representations, 0 and 1. But if you ask me here, there are infinite n number of possibilities. Okay, so this can be done by using qubits. Now, can you tell me what kind of computer I am talking about?
Quantum computing.
Exactly. So let me tell you, quantum computing is going to change the complete curriculum of engineering if it is going to show us results like entanglement, then superposition, and NASA and Google AI, they are claiming that they have quantum supremacy. They have achieved quantum supremacy. So if we achieve that, I am sure that the complete basic electronics textbooks will be changed. If you want high-speed computing, quantum computing is the future. If you want intelligent computing, neuromorphic engineering is the answer. But it will also create a question. What about the VLSI, where we are doing system Verilog, we are doing verification, we are doing various kind of RAM devices, we are designing various kind of embedded systems, processors. They will be there, but they will be appreciated according to the application. If the application is everyday general use, then it will be designed by VLSI, which is existing and which will be about parallel processing, which will be about fast hardware accelerator based kind of processing. But if you want intelligent kind of processing in the VLSI, then it will be neuromorphic engineering. Okay, and there will be also a resistor which will have memory. Okay, and that is called as memory resistor, a resistor with memory. So the current problem of memory or storage devices is they are very, very volatile. Yeah, when we have come to memory, let me also add some details here. The storage memory, what electronics is a person has to design. So he will be working on SDRAM, okay, and also magnetoresistive recording. So that can be magnetoresistive recording or magnetic recording and magnetoresistive RAM, I can say. Shingled magnetic recording. Then there might be helium drives. So they are the upcoming things what we have in our research domain in electronics, where memory is being worked upon. And also, as I said, when we work with data compression, the biggest data what humans have is human genomics. And if you see how our genetic information, the code has been stored, where is our genetic information stored in our body? What do we call it as? Very good, very good. Now, the new kind of memory will be inspired by DNA, and it will be called as DNA storage. They are beyond parallel processing, and they are about distributed environment. So this kind of distributed environment will have a distributed storage, and that storage is autonomous. Every cell has its own DNA, but all DNAs are same. So this kind of concept will be there in the storage memories. So if you are an electronics engineer, if you are doing a project, then you can go with embedded systems at UG level. If you are an engineer, electronics engineer, and if you want to be, if you want to get a job, then you can go with information processing, parallel processing, virtualization. But if you are a faculty and you want to do research, then you have to go for intelligent computing, that is about neuromorphic engineering. You should also look for the fastest way of computing, where you have more number of possibilities, that is called as quantum computing. The entanglement and the superposition are the biggest concepts, and which is very, very green, and it will help you to achieve super fast computers with least resources. Let me tell you the capacity of quantum computing. Quantum computing can solve something which in seconds, which a regular computer can take years together. Like for example, I can give chess moves. Okay, here, if you want to achieve 200 million chess moves per second, then it is possible from our computers, current day computers. But if you go for quantum computing, okay, it will be 1 trillion moves per second. So there is almost a 5,000 times increase in speed. Okay, so now coming back to software domain. Now I have sensors which gives me huge data, and that data is coming and I am learning from that, and I am making the machines intelligent. Now there are small devices which are executing that without the need of large servers, and with the use of cloud and the edge devices, I am doing everything. What about security? What about the sensitivity of the data? What about privacy here in this domain? So they are the biggest concerns. So if I cannot achieve security and privacy, then I might not see that there is a future for this particular device. All these devices, they create a seamless environment ecosystem. These tiny computers, can I call it them as IoT devices, Internet of Things? Okay, and Internet of Things over a city is called as cyber physical system. And when we have tiny computers, they are IoT devices which have sensors embedded on that, and the complete ecosystem with all the providing services. Like for example, IoT is implemented or deployed on all the driverless cars, but the complete traffic system is called as a cyber physical system. Now, the domain.
Sir?
Yes, ma'am.
Sir, someone has committed like blockchain technology with help.
Very good, very good, very good. So the person is one step ahead of me. Can I call the security in this cyberspace as cyber security? And in this space, when everything is digital, okay, and when everything, every data, every information is in digital, I need some safety for that. Okay, then what I will do, I will take this digital information and I will create a hash of it. Okay, hash function of that, and create a block of information. Okay, hashed block, and connecting each block with chain with chronological order. As the person is very fast, he has answered very aptly. It is about blockchain. So when we talk about security, especially in this cyber physical systems, it is about blockchain. And when there is a blockchain, there are many transactions. And this blockchain is a democratic way, that is, it is not bounded. It is an open ledger for everybody. So it cannot be bounded by one particular country. So when all the information is in digital domain, there should also be transaction in digital domain. And for the transactions, there should be a currency. So that means whenever there is a blockchain, there should be a digital currency. What do we call a digital currency on a blockchain?
Bitcoins.
Very good. So there are many coins in terms of bits. So we have Bitcoin, and there are many cryptocurrencies which are safe because they are crypto. So because they are hashed. So since they are hashed, they are safe. And since it is a distributed ledger, all the information is also safe. So in the blockchain, we need to have cryptocurrency. Let me tell you, this is also a disruptive technology. Blockchain is also a disruptive technology. So for example, if you are working on various cyber physical systems in IoT, if you don't embrace blockchain, then it is a somewhat old topic. So if you are doing research on IoT devices, for example, all the medical records, they are saved somewhere, then that has to be secured, and the privacy of the patients has to be maintained. The patients will give their consent only when it is safe, and it is maintained privately only for research and analysis purpose. That can be done only by blockchain. So blockchain is an open ledger where all the digital information in the complete cyberspace is made as a block, and every next block is connected through a chain by the hash function of the previous block. The complete block has been hashed, and that hash code is given as a part of the header to the next block, and next its hash is given to the next block. In this way, there is a chain of blocks which is called as blockchain. And also blockchain is going to disrupt the complete system. Having learned about all these things, okay, so there is insight, there is data, there is cloud, there is machine learning, there is deep learning, there is container, there is Docker, there is virtualization of hardware, there is hardware accelerator, there is neuromorphic engineering, there is quantum computing. We have not focused, or we have not discussed about the speed at which the communication should happen. So with these things, I want to have a driverless car. Okay, so I will take you through the journey of these devices. A driverless car should have a sensor, okay, which will see. So that means a driverless car should have computer vision. That means it should have a smart device. Now this smart device is generating data. That means you need to have big data. And when you have big data, you need to store it somewhere in the cloud. And when there is some trained model in the cloud, that means the car has to take immediate decision. Then if you wait for the cloud to respond, then it will be very late. There might be accidents. So for that, you have to shift the complete capacity of cloud to the edge via shipment. That means the edge device in driverless car should have intelligence. So you need to have a sensor, you need to have cloud, you need to have data analytics, then you need to have edge device, then you need to have deep learning models in edge devices. And these deep learning models in edge device can be only executed by hardware accelerators. And because of that, they will take a decision. That means there should be intelligence, the decision making, and then the car is said to be intelligent, and we can work out with this. Now, with all these things, there is a sensor which is very, very hi-fi. And let me also tell the research domains in embedded systems. When you talk about sensors, if it is of light, then it is optical. And if you talk about very small size, it is about MEMS. And if you want to go much beyond MEMS, then there is nanotechnology. So these are the things what we have, the research domains in electronics domain at the physical level. The physical layer, if you want to work on the physical layer, that means you want to design a new sensor. For example, I want to measure the blood glucose level and it should be as small as possible. Then you have to work on optical devices or MEMS, or you have to work on nanotechnology. If you want to work on cloud, but being in electronics engineering, then you have to work on new type of memory devices. If you want to work on information plane on machine learning, but you want to implement that on hardware, then you have to work on virtualization of hardware, parallel processing, and you have to work on NVIDIA's GPU. If you are in the implementation domain where you want to implement on the use cases and you want to work on IoT and blockchain while providing security through cyber security, then you have to work on new kind of processors that should be either fastest or they should be intelligent. You can go with neuromorphic engineering, you can go with quantum computing, and everything is okay and everything is done, everything is there. What if the response is after 20 seconds after detecting the obstacle? Some old person is crossing the road and the driverless car has detected and it has sent the images to the cloud, and the cloud has done some data analysis. It got inside that yes, there is an old person whose speed is very, very less. That means we have to apply brake. The intelligence has taken a decision and it will send it to the edge to apply the brake. The brake has been applied after 20 seconds. I cannot avoid the accident and the driverless car cannot be prosecuted. So what is required here?
The processing speed should be increased.
Very good. So that means speed is the need for everything, whatever the glitter and glamour, the beautiful things we saw till now is only and only possible if we go more beyond our electromagnetic spectrum. That is, if we go to 5G. In 5G, it is not only about voice and data. It is about many things. It is not only about your cell phones. It is about robotics. It is about drones. It is about augmented reality. It is about virtual reality. Let me list those applications since we have applications here. So it is beyond voice and data like VR, AR, or mixed reality. It is about robotics. Some of the participants had answered it previously, and drones. It is about user experience. This kind of
We got a comment like we need to work on latency issues in cloud and sensors.
That's very good. Very apt. That is what is the research topic many people are working, including one of my students. So we have to reduce the latency, and that can be done when we move more towards the spectrum. So this is my second part of the presentation where I only focus on 5G so that we can see what kind of improvements can be done in communication. So here, up to this point, I have discussed on electronics. Okay, and this part I am going to discuss on communication because as the name says, we are working on electrons and communication, the advanced topics of this FDP. So I hope I have made very right points, and also the open research issues and the overlapping domains of computer science and electronics, which are working towards that. So this 5G, which is beyond voice and data, it is about virtual reality and augmented reality. It is about mixed reality. Robotics and drones are possible only with that. User experience is possible with that. And industry 4.0 is possible with that. Web 3.0 is possible with that. Without this, without 5G, all the things what I said They are just good for blogging and they are never going to be realized in real time. So my remaining part of the presentation now, I am going to talk about 5G. Hope this has made some sense and it has created some questions among you. Can I just get a feedback from the organizer, like was it okay, this kind of methodology?
It was very nice, sir. The session was interesting.
So it is engaging, right?
Yes, sir.
Okay. So also let me take you through PowerPoint presentation of 5G so that it will also help me to go much forward in this particular discussion. So we have discussed about electronics. Now we are getting deep into the communication. So here is my presentation for 5G. So I am demystifying 5G, but it has been demystified already, and it is very past time. Like it is very late to talk about 5G because almost 19 countries have already implemented that. So there is nothing to demystify. But for faculties, it is about demystifying the research avenues where 5G, if you work on 5G, what are the things, what are the places you can do research and where all you can patent more. This is what I am going to discuss, but I will rush through the contents. These are the 5G use case scenarios. One is about enhanced mobile broadband. That means, let me tell you first thing about the gravity, create gravity about 5G. At the end of 2020, 1 billion people had coverage of 5G services. And it is escalated, or it is estimated to escalate to 2.8 billion by 2025. That means just in 3 years, it is going to be threefold of whatever has been previous in 2020. Between 2020 and 2026, global 5G service market has shown a potential of annual growth rate of 30%. Okay, and as I said, it is very critical for all kind of applications, including the industrial revolution, industry 4.0, and it is also including the web 3.0, and it is also going to revolutionize the agriculture sector and education sector, all those things. It is going to also boost the global economy by $12 trillion US dollars by 2035. So that means you are into communication. This is the right time to know what is 5G and also go beyond that. Okay. So coming to 5G, these are the three verticals what people are looking for, what the researchers are looking for, what the standardizations have decided that these are the things which I want in 5G. So URLLC, ultra reliable and low latency communications. The latency should be very, very less. Okay, it should be around 1 millisecond latency. As one of the respondents said that we have to reduce the latency. So this is the solution. 5G is the solution. And how do we do that? We will see that in next slide. But these are the requirements. These are the verticals which have to be satisfied by 5G. If these use cases, these scenarios are implemented by 5G, then the technology is set to be 5G. Else, it is just an update over 4G, but we are soon going for searching, we are soon going to search for solutions in 6G. So 5G has to provide these solutions. It has to provide 3D video, ultra high definition screens, work and play in the cloud, augmented reality, industrial automation, mission critical applications, and self-driving car. Self-driving car need more reliability as compared to broadband. Broadband is required, but for a driverless car, the decision should be very, very fast. That means the latency should be very less. In 4G, the latency is 200 milliseconds, and a human eye responds in 250 milliseconds. But in 5G, I am expecting 1 millisecond of latency. So it is almost 200 times faster than your 4G. That means if a driverless car stops after 30 meters of identifying an object, a driverless car enabled with 5G, it will stop within 3 centimeters. And according to 5G standards, a driverless car should detect an object and stop within 14 centimeters, 1/4. So 5G is well within the limit and much better. And this is what is expected from 5G. At one place, there is a requirement of ultra reliable, low latency communication. At another place, there is a requirement of massive machine type communications. That means your cell phone should talk to your coffee maker should talk to your geyser should talk to your car should talk to the traffic management, and your car should also talk about your commitments and the emails today, and your email responses should talk to the bookings in the restaurant. All this should happen at the back end. They should be autonomous. They should happen on their own. Let me tell you a very simple example. Whenever I travel back from my place to Yeshwantpur railway station, the moment I get down, and before getting down, what I will do, I will book a Ola cab. And when I book the Ola cab, I also get an invitation from in the Ola from the Swiggy that do you want to have dinner in half an hour? So if I say yes and I do the payment, then the food will be delivered to my home even before I reach my home. And I have not seen the people who are preparing the food, and I have not given the payment in cash. Everything is at the back end, and everything is just one click away. And when I come back, when I onboard the car, when I get into the cab, I will get a message from Savan, and it will continue from the song where I left last time. So where I paused the song last time, it will continue from there. That means my playlist is in Savan, where I am a Prime member, and that Savan is collaborated with Ola, and that Ola car knows where I stopped my last travel and where the song, which was the last song, and where it was stopped. It will continue from there. And this seamless kind of interaction is what I'm talking about, ubiquitous computing. It is about pervasive computing. That means computing is very easy. It can be done in your watch, it can be done in your light, it can be done in your fan, it can be done in your system, it can be done in your pen. That means computing can be done anywhere. That is why 5G is required. If it is to be done in only cell phone and computer, then 4G is sufficient. But if you want your antennas to communicate, if you want your traffic lights to communicate, if you want your logo to communicate, if you want your house to communicate, you need 5G. And that 5G is enabler of massive machine type communication. So the moment I get off the train, I board the car, my food is also ready at my home, and my playlist is also playing there, and my preferences, everything is taken in the backend, and it is working there. This is where innovation is required. This is where you can start a company by a simple idea. Have an idea, create an app, pitch in, generate funds, and get the funding. You will be an entrepreneur. Professor is the last thing to be done, because a professor is the most experienced person in industry, in startup, and in teaching. The problem is we assume professorship at very early age and young age because we have been exposed to that system. But from your heart, you should be an engineer, you should be an entrepreneur, then you become a teacher. Now you can be a professor. Don't take your teaching job seriously until you are a serious engineer. Don't take your engineering job seriously until you are a true researcher. Once you are a very good researcher, once you are a very good engineer, once you are a good entrepreneur, obviously you will be a good teacher. And your mentoring will help many budding startups. So these are the three cases of 5G. This is for more broadband. Technology enables. 5G is just not a fiber rollout. If you have seen, the BSNL has laid out many fiber lines, and just laying out new fibers is not 5G. And 5G is not just about voice and data. Hardware equipments need to be redesigned. Why? I'll tell you. Antenna numbers, location, and operations must be changed. Since we are moving up in the frequency, there are also challenges which limits our 5G applications. The communication protocol need to be reworked because we are talking about massive devices which don't even have a screen, which don't even have a speaker. We are just talking about devices which have chips. Any device which has chip is an IoT device which will be under the coverage of 5G. So these are the enablers of a 5G. Millimeter waves, small cell, massive MIMO, beamforming, and full duplex. Due to the lack of time, I will be rushing through that. Now 5G is about two frequency regions. One is from 3.4 up to 4.2. So 3.3 to 4.2, this is FR1, this is frequency range 1. This is one 5G. And there is another band which is saved also, which has to be explored for future. But one small confusion I want to clear among all the people here. There are some people, environmentalists, who says that because of the waves, there are no sparrows. Let me tell you, sparrows doesn't exist based on the waves. Sparrows exist based on insects. If they are not getting insects, that means the forest is not there. If there is no greenery, there will be no sparrows. It is not because of 4G. Mobile communication has nothing to do with radiations because this is visible light. If visible light is not harming you, then that means any wave before that is not going to harm you. After visible rays, there are ultraviolet, X-ray and gamma rays. These are going to harm you, the red zone, ionizing radiation. So any of the student who says that, sir, because of waves, because of cell phone towers, there are birds which are dying, let me tell you that it is not because of waves, it is because of lack of greenery. Since there is no greenery, the insects are not available, and if the food is not available, there will be no birds and sparrows everywhere. So the 5G is good, it is safe, there is no problem with 5G, and it will be good up to 750 terahertz, and we are still in 3 to 4 gigahertz. That too we have not exploded completely. So we can go up to 60 or 50 gigahertz in 5G. This is called as FR2, frequency range 2. So when we increase the frequency, the wavelength reduces. Here, if you see, the wavelength is more so that they can penetrate through building. But when the wavelength is lesser than the thickness of the building, they will get reflected. That means 5G has high frequency, but it is going to be absorbed or scattered very fast. That means it cannot travel a long distance. So wavelength decreases, therefore the wavelength is represented in millimeters. Hence the name is called as millimeter wave. And if you see here, these are 3GPP towers with 3G connection. So if they are here, it will be almost like 1.2 or 1.8 kilometers. One tower and another tower is placed away from them for about with a distance of more than 1 kilometer. But if you come for 5G, they should be within 30 meters. So within 30 meters, if you can provide the antenna, then only 5G is going to be successful. So that means you need to appreciate millimeter waves, and you have to work with that. You have to appreciate the towers within small range. That means you need to have small cells. Then only you can appreciate it for long. So if you see here, with 4G, you can reach everybody, but with 5G, you need to have 2 repeaters here. Then only it is achievable. This is the large base station. This is small cell. This is another small cell, which is here. So when you have more frequency, then the size of antenna is very, very small. And when the size of antenna is very small, that means they can place it next to each other. And when you can place them next to each other, then high data rate with focused beam can be done. So we can have multiple input and multiple output towers. Previously, what we used to do here, if you see, the beam is like sent everywhere. There is a pollution of beam also. But if I have multiple antennas for 111 streams, then there will be one particular application. Your single cell phone might be interacting with 10 different antennas, because you also have a MIMO antenna, and the transmitter at the base station also have a MIMO antenna. So all they are interacting with each other, thereby giving high data rate, and there is independent. Okay, there is a separate socket, separate session for every transaction what you have in information and data received. So beamforming is very important. When you want to send it to a large number of devices, there will be inter-symbol interference. Okay, when you communicate to many devices, there will be inter-symbol interference. To avoid that, you have to focus the beam. That means instead of this beam, you have to create another beam which is more focused and which will reach to the receiver at a large distance, but with more focused beam. That means energy will be more. So this is beamforming. And also full duplex. That means I cannot say that the upload speed is 1 gigahertz and download speed is 800 hertz. They should happen on the same speed. They should happen with the same exact 1 gigahertz. The upload speed should also be 1 gigahertz. Download speed should be also 1 gigahertz. In a driverless car, the image which has been detected, it should be uploaded with 1 gigahertz, and the decision to apply the brake should also be focused and delivered with 1 gigahertz speed. So these are the things what we have, and these are the things what we can discuss, like 1 millisecond latency, and it is 10 years of battery life what we need as compared to 4G, and it is 100 times more devices. It will be connecting 100 times more devices as compared to 4G, and it will be connecting 1000 times more as compared to 4G. Like that, we have more metrics. And this is a beautiful area for research, for PhD. If you are working on wireless sensor networks or IoT, embrace 5G and work on network slicing. The complete network has been sliced, and that sliced network will be orchestrated. So the hardwares are virtualized, just the way we have virtualized software. Software virtualization is called as Kubernetes. Whereas hardware virtualization is about VMware. Here we are virtualizing network. So when we are virtualizing everything, there is a new domain called as twin, digital twin. Anything which is physically available, it will be available on the digital domain. Like when you book a cab, Ola, you can see the movement of the car in your app. That means whenever the car is moving on the road physically, there is also a car moving on the digital domain. So there is a twin. For every physical thing, there is a twin on the digital space. You can see me on digital space. For example, what I am doing right now, you can see that on my LinkedIn. So these kind of things will help us to have more seamless kind of technology appreciation. So if you are looking for PhD, if you are looking for research, these are the domains where you have to focus on: network slicing, function virtualization, and the complete orchestra of that. Orchestration means playing different things at different times to create a beautiful music out of that. So similarly, sometimes you take cloud, sometimes you take edge, sometimes you give more importance to security, sometimes you give more importance to data. By this, you will apply and you will create beautiful applications like driverless car. You will create beautiful applications like virtual reality, augmented reality, and that is how we are going to create the beautiful world. And if you want to enhance more, then you bring AI and ML or deep learning things in these three domains, three verticals of 5G. So to take right time decisions, you need AI ML. To have closed loop actions, that is autonomy, you need to have AI ML. And also to have real-time insights of the data, you need to have AI ML and deep learning. So AI ML are not just computer science domains, they are interdisciplinary domains and they are sciences. So use them because you are an engineer. Use all the sciences to make your engineering product as best as possible. So 5G deployment is not simple. IoT and edge computing, Industry 4.0, Agriculture 2.0, Smart City, they all can happen only if 5G is there. Even the drones and robotics, they all can happen only if 5G is there. Hardware, software, and network operations are completely different for existing things. So complete change of antennas, change of communication, change of bandwidth will happen if we implement 5G, which is very much inevitable. Skills for the future engineers and revenue models has to work. And this is the revenue model, or sorry, this is the revenue and the market size of 5G communication. These are the companies which are working on 5G. These are the verticals like manufacturing, energy, utility, media, and entertainment in 5G. And there is a regional outlook what we have here. So there are many countries which are working on this. With this, I come back to the communication domain, and I would like to conclude that the session was named at Advanced Electronics and Communication Topics. And with the development of computer science domains, I have coupled it with electronics hardware, that is VLSI domain, and I have coupled it with signal processing domain, and I have coupled it with communication domain. I have tried to do more justice to the title, and I hope it has reached the wider audience, and it has created many doubts in you. And there are many topics which I have skipped in the runtime, but that is for your takeaway. Here, I would like to comment on the end that if you are not adopting technology, you are outdated. If you are not talking about technology, you are doing procrastination. That means you are delaying, you are lazy. If you are not building technology, that means you are not building the future. And if you are not investing in technology, then you can never be super rich. So our religion should be technology now, especially being engineers. We should adopt technology. We should talk about technology. We should build technology, and we have to invest in technology. By then, we will be very relevant professor. We will be very active professor. We will be a future ready professor who are building the future and future entrepreneurs. And also we will be rich professors because we are investing in technology. So these are the things what you have to focus. And my takeaway from this session, what I want everybody to have is, sometimes we faculty, because since it is a faculty development program, having said everything, if I don't tell how the faculty should develop, then there is no meaning in that. It doesn't make any sense. So a faculty should be multidisciplinary. That means whenever a student comes to you and say that, sir, I want to work on air pollution, you should have an open mind to work on that because it is environmental engineering. If a student says, I want to work on quantum computing, you have to be open mind towards that. If some students say, I want to work on big data, I want to work on blockchain, I want to work on 5G, I want to work on IoT, you should be open for all the avenues. So you should be open for all the technology. Then only you will have more publication and you will have more understanding. If you tell that only designing an antenna at 5 gigahertz is my domain, you might have 10 or 100 papers in that. But whenever somebody talks about quantum computing, you are irrelevant. You should know something about everything. And later it is up to you to know everything about something. But as a professor, you should be multidisciplinary. You should know something about everything. This is one important takeaway what I want every professor here who is attending the session to take it from this session. The second is programming is a necessary skill of 21st century. You cannot say that I am an electronics engineer and I don't want to program. Programming is a skill. Even if you are a BCom graduate, even if you are a BA graduate, even if you are a BSc graduate, you should know programming. It is not the job of computer science engineers. Just to know how the things are working, you need to know programming. So if you want to innovate, you don't know how to innovate. Many times we try to innovate, we misconceive that doing a project is innovation, writing a paper is innovation. But let me tell you, innovation, there are many innovations which have gone against the humanity. Okay, and the right kind of innovation has to happen. And for that, you have to first design the way you think. So design thinking is the innovation literacy. If you are going to do innovations without design thinking, I am sure it may end up in complications. But if you do some innovation with design thinking, it will be more sustainable, and it will be for long term. So learn about design thinking and make those products and solutions which are going to be sustainable. My important takeaway for all the faculties here, more on research than teaching. Let me tell you, there are best teachers available in the world who can teach your students much better than you and me. Okay, so no need to think that I am the only person who can teach this better, and without me they cannot understand. There are many best materials which are much qualified and there are good exposures to that. So you have to be a researcher, and if you do research on that, you will have the maturity to understand at what potential the student can take the product, the student can be a good engineer, or at what level the technology can go, and you can invest in the right technology. Okay, so work more on research than teaching. That doesn't mean that you should ignore teaching. You are a teacher by default, you should be a you are a teacher, and by default you should be a teacher. There is nothing called as good teacher or bad teacher. If you are bad, you should not be a teacher. There should not be best teachers in the society. Only the best people in the society should be made as teachers. So you have to be a researcher while you already are a teacher by profession, that you think every time about how to deliver something to the information, to the best knowledge of the students. And the last takeaway is try to be an engineer. Try to be an engineer. Just try. That's all. I am not telling you that there are no labs, there is no MATLAB, there is no NVIDIA Jetson kit at your home, or you don't have access to all those technologies. No problem. Neither do 87% of the teachers have. None of them have. Almost 87% of the teachers don't even have the access to a ledger, to a blockchain. No access to them. But you should try to be a teacher. You can just download Anaconda package and run a Python code for machine learning. And if you teach that to your student, he will end up with a good job, and he will have a startup, and he will employ you as a mentor for a startup. So these are the 5 takeaways what I want to give it to you. Be multidisciplinary from your mind and think from humanity, that is empathy perspective. So do design thinking. Let programming be a part of your skill, and let teaching be at the back end while research is your front end. And also strive to be engineer. With these things, I am sure that any faculty, including me, will develop into a very good faculty, and all such FDPs will have meaning. Thank you. I have come to the time where I have to conclude the session. So I hope I have made sense, and this is a new kind of pedagogy. I'm sorry if you are expecting a PowerPoint presentation, but I have shown you that even I can do PowerPoint presentations as a proof. So I have made 5G in PowerPoint presentation, while this was, I wanted it to be more interactive, because this doesn't explain you what are the things, but this makes you or gives you a layout how to relate different technologies and understand them and have maturity over them. I don't know blockchain, but I can speak on blockchain. I don't know quantum computing, but I can speak on quantum computing. That confidence I want to give to all the professors, all the faculties attending this particular FDP. And I hope I have made my effort, and I am sure that it is going to trigger many innovative thoughts in you, and it will make a fruitful session for you, for your future, and also for your profession. Thank you. Over to you, organizer.
So we have a few questions from the participants, sir.
Sure.
Yeah. So one asked, like, if radiation is not harmful, why there will be signboard saying ionizing radiation near cell tower houses?
Very good. Here, there will be ionizing radiations at the cell tower, and there the base station will have a small part of it, but it will not be on the public domain. It will be only at the development domain and the main station, not the base station. So that is not a problem. Same signs will be used in hospitals. If you see near the radiotherapy, especially in the cancer treatment places, and even in the X-ray rooms, the same kind of ionizing symbol will be used. But at base stations, seldom it is used. It is never used in public. And 5G is here. So there is no question that there is some ionizing effect. See here, it is non-ionizing radiation. This part, which is 30 picohertz, okay, beyond the terahertz, it is about ionizing radiation. I hope I met the expectation of the question.
So can we mix the VLSI with quantum computing?
Much, because this entanglement and superposition are very important, but it is in very novel state. We don't even know how to create a kind of tank. It is actually interference is a big problem in quantum. So once we overcome the interference, then only we can work out. And the cost of implementation is also very high, because complete gold is used in a quantum computer system. So as of now, if you take a domain with quantum bits, qubits on VLSI, that might be a good research topic, but I cannot say that complete quantum computing can be implemented on silicon. I doubt about that. But silicons show superposition, silicon atoms, electrons, they show entanglement. So there is also possibility. But I am limited by my knowledge to say that complete quantum computing can be only made into VLSI domain. Any further questions?
Participants, you can also post the questions in the YouTube chat box. So like most of the participants commented that the session was excellent and very useful for them, sir.
I'm grateful.
It was very interesting as well.
Okay, I am grateful and I am humbled that they try to adopt to this kind of presentation, and hopefully I will try to be much better and efficient next time. And thanks for being such a lovely audience. I am grateful to all of them.
Sir, we will wait for 2 to 3 minutes, sir, for posting the questions.
Sure, ma'am. Meanwhile, the faculty members can also ask any question related to research. If I know, I will try to answer, or if I know where to find the answer, I will also, I can guide accordingly.
So we have a question from a participant He's asking that, yes, without that, nothing can be implemented physically.
Mhm. So what is the question? Like, it is a conclusion? Without that, nothing can be implemented. That is what we felt it after the discussion of 5G.
Yes, sir.
So without such a high-speed data, you cannot. Without communication, electronics is paralyzed, and it is just a hobby. Electronics picked up only when we married it to communication. So this union, the holy union of electronics and communication, has given rise to such potential applications where user experience is kept at the highest end. Else, electronics itself just a hobby, and it will be a part of electrical engineering. And communication is always necessary, just like transportation. Without transportation, how backward we will be. In the same way, without a communication, electronics will be as backward as we will be.
So there is another question. So there is no Moore's law applicable in Q computing.
There is no more.
Moore's law applicable in Q computing.
Yeah. Moore's law is reaching its limitation. Like, for example, we have 2 million devices, 2 billion devices, transistors on a single chip. That means you can going on reducing the size of transistor. But can I reduce the size of a transistor lesser than an atom? I cannot have a transistor made up of only 5 atoms. I need to have bulk silicon ions and substrate to have a transistor. So there is a limit on that, and quantum is no way going to talk about Moore's law. And Moore's law is going to be outdated, and not outdated, I say. It was required from the transition of 1970-71 when Carver Mead, let me give respect to him. Carver Mead is a person who coined the term VLSI and who started the domain of VLSI, and his friend from Fairchild company, this friend was Moore. He used to supply the wear out chips, whatever is manufactured in Fairchild, whichever is damaged, that was supplied to Carver Mead. So Carver Mead was a professor, and Moore was a marketing person. So Carver Mead told him in the discussion over a cup of tea that see, every time we design, and the technology is growing so much that I will be capable of designing more transistors, almost double for every 18 months. So that is what Carver Mead said. And when Carver Mead said that, Moore observed it over 5 years. And after 5 years, he came back to Carver Mead and said, sir, whatever you said, it is true. And then he created his law. Then it was famous as Moore's law. But let me tell you, it was the professor Carver Mead who told that the transistors can be doubled for every 18 months of the technology improvement. And yes, Moore's law says that we can double the transistor by reducing the size, but can I reduce transistor below an Armstrong? That is the unit of the length. Or can I reduce a transistor lesser than an atom? So you go on compressing, but you cannot compress lesser than an atom. I cannot say that there are 5 transistors within an atom. That is highly impossible, which we cannot achieve. And if there is a technology, let's see, but it is highly impossible with our current existing thing. So if we cannot reduce transistor below an Armstrong, or if we cannot reduce transistor size below an atomic size, then yes, Moore's law is outdated.
Sir, Mr. Kannappan has asked that, sir, can distributed memory-based VLSI circuits be chosen as a research topic?
Excellent. I appreciate that. I know even I want to be part of that. If sir is taking that topic, I would be happy to either review or to contribute for that. It's the future. That is the future. Distributed memory. Let me tell you, when you start learning driving, okay, you focus completely on your driving. But after 10 years, your body has the memory and it is driving. You don't even know that you are moving from your college to your home. You have driven all the way. You have applied the brake. You have increased the gear. You have increased the speed. You have reduced the speed. You have applied the brake. Everything is done when it becomes your body memory. So the complete body has a memory. It is not only about in the central nervous system. Our human body has memory. If you keep on telling that I am going to lose weight, it is going to lose weight without doing a single activity because it has memory. When you speak to your body, it responds. So if you want your machines to be as intelligent as humans, you have to have distributed memory. You cannot say that go to the memory, fetch this data, process it. That days are over. Such kind of devices will not work. You have to implant devices in the human body which has to work in synchronization. So distributed memory computing is the future, but you have to identify the right tools, how to execute that. The problem with such new technologies or the trending topics is there is no lab which will help you to show the results. The only way what you can do is you have to do with simulation. It happened with me, with my first student, PhD student, BV Prashant, who is working on spintronics. So it is about exploiting the spin. So if electron is moving, 0. If electron is not moving, then it is 1. Like that, we can take a convention. And we can take another convention of spin. If it is spinning positively in one direction, we can take 0, 1. If it is spinning in other direction, we can take it as 1, 0. And if it is not spinning, and if it is spinning, there are multiple possibilities of that. So spintronics is the next way to quantum computing. So when we tried to implement spintronics in our lab, there is no facility for that, and we don't even know what kind of devices we want. Then we approached Surabhi Gupta in Japan, where she was working on in the physics lab. She permitted us to go there, but a pandemic happened, so we were not given visa to go there and execute that for 3 months. So later we were at the mercy of Python. So we created a code of entanglement. We wrote a code. We wrote code on our own in Python, and that code was executed to prove that spin, and also which is going to lead for quantum in atoms. It is a very good domain, but you should know how to prove it, either by experimental or by computational. So since we don't have access to lab, and many colleges don't have, many universities don't have, I recommend that he should know how to prove his, how to argue his, how to defend his title with computational models, theoretical framework, conceptual framework. Then only it will be helpful. Else, he will keep his first step on the last rung of the ladder. Neither he can move up nor he can get down. That is one alert what I want to give to sir.
So Mr. Umakant has asked, are they using quantum computer in processing the huge data that's generated during practical collision in Large Hadron Collider?
The question is way more technical and it is beyond my knowledge. But yes, if we can apply, there might be possibility, but quantum computing has seen only 3 to 4 applications till now that NASA and Google AI, they have tried. And also there are other companies who are claiming that they have achieved quantum supremacy. But I doubt that it has been implemented right now, but it can be taken as a research question, but I am limited by my knowledge. I don't have idea how it can be used for hydrogen collision.
Now, I request the convener, Mr. M. Imtiaz Basha, sir, to give a vote of thanks for today's session.
Before that, can I thank everyone, ma'am?
Yes, sir, sure.
Yeah. First of all, I would like to thank Gates Institute of Technology for thinking beyond what is reachable. And when we think impossible, then only the vision will help us to get motivated. There should be always a reason to get up in the morning and come to college. this kind of FDP will help each other to know what are the things we can talk about beyond the regular things. If we talk about ideas, I think we are going to be the most effective and productive citizens of the country. So if we talk about technology, it is almost like a worship and a service to the nation. With that vision, I am thankful to Gates Institute of Technology to have thought about such a FDP, and I am grateful to all of you for giving me an opportunity to speak on the day one. Especially, I would like to thank Padmavatama, the correspondent, Srimati VK Padmavatama. Thank you, madam. Madam Srivani, director. Dr. Venkatesh, principal. Imtiaz Basha, HOD of Electronics and Communication Department. The coordinator, thank you, ma'am. You have very good voice, and thanks for navigating me through the answers. And also, I would like to thank co-convener Dr. R.S. Kavita, madam, who had approached me 1 year before for this FDP. Somehow I didn't respond for 6 months, but she is having very good perseverance. She persuaded me, and I am very grateful to her. Thank you, madam, and I hope I have met your expectations. You wanted to give a very good exposure to your faculty students at FDP, and you chose me for the first session, and I hope I have met your expectations, and I also will try my best to improve my presentation for the further engagements. I would also like to express my willingness to be associated with the Gates Institute of Technology in any means, even for a student development program, for a guest talk, and I love to speak offline if possible. Thank you one and all, and over to you, madam.
A very good afternoon to one and all. It gives me an immense pleasure to deliver the vote of thanks for today's session. On behalf of Gates Institute of Technology and Department of Electronics, Communication, Engineering, we as a team wholeheartedly thank today's speaker, Dr. Mohammed Riyaz Ahmed, for giving valuable insights on quantum computing, neuromorphic engineering, deep learning, 5G, blockchains. It was a package starting from sensors to a driverless car applications. So once again, we thank you very much, sir. And once again, I thank all the participants for present here. Thank you.
Thank you, sir. Thank you very much, sir. I will share this data with the co-convener Kavita madam, and hopefully you can give it to the participants whoever requires that. I will share the presentation of 5G also.
Okay, sir. Thank you, sir. Thank you very much, sir.
Thank you, sir. Thanks for the opportunity.
Yes,
I would love to see you all offline. Hope we will get the opportunity very soon.
Sure, sir. Sure, sir. We too expecting the same from you, sir.
Yeah.
Thank you, sir.
Thank you.
And thanks for all the participants for contributing your time and presence in today's FTP. As usual, we will be meeting for day 2 session tomorrow at 11 a.m. to 1 p.m. Thank you all.